All right, so now we're looking at similar right triangles. So we've talked about similar triangles. We've talked about different proportions and different ratios. We've talked about special right triangles, and now we're talking about special conditions about right triangles that make them similar. All right, so right here, if we have a right triangle, we talk about two legs are the shorter pieces. We got the shortest, the middle, and then the longest. The longest we call the hypotenuse. This is review. We've talked about this before. Now, if I drop down a perpendicular line through the vertex of the 90-degree angle right here, and I create another 90-degree, this is called an altitude. It's a vocab word. Altitude means it's 90 degrees, and it goes through a vertex. There's three of them. This one specifically is what we're talking about, and we're going to talk about it as altitude, leg, and hypotenuse for today. So get familiar with that lingo, the wording, okay? So notice how the altitude cuts it into two different pieces. We have AD and DB, so the hypotenuse is in two different pieces. One of the fractions that we get out of this setup, it has to be a 90-degree triangle and it has to be an altitude off of the 90-degree angle. We get one piece of the hypotenuse, so like AD, fractioned over the altitude is equal to the altitude divided by the other piece of the hypotenuse. This is one true fraction we get when we look at this this particular shape. We can look at the actual, what it talks about as part of geometric mean, because the leg is the kind of like a geometric mean. But now if we look at the entire hypotenuse, AB over a leg, we got to specify which leg. So we could say AC or we could say CB. And then we use that same leg over top of the piece of the hypotenuse adjacent to that leg. So here's AB over AC is equal to AC over the piece AD, because it's connected to AC. And it'll make a lot more sense when you look at it, but here I just want to show you what it looks like on your cheat sheet. Okay, here's the piece of hypotenuse over altitude equals altitude over the other piece of the hypotenuse. Or the full hypotenuse over a leg is equal to that same leg over the piece of the hypotenuse that we want. Okay. So there's going to be 5 problems on the test, 3 calculations, and 2 formulas. It's on your cheat sheet. Get familiar with it. Okay, so if we look at our first example here, I have to find the information. The information I'm looking for is x, and it is a leg of the triangle. Okay? So I look at my equations. Piece of hypotenuse, altitude, other piece of, that doesn't have a leg in it. Nothing in there discusses a leg of the 90-degree triangle. So I know I'm not going to be using it. All right, so when I look at this, I say it's a leg. X is leg. So if I look at my equation, leg and leg, that's the equation I'm using. Notice how it's a 5. 5 is the whole hypotenuse. And then we have x is the leg, so it goes here. X is a leg, it goes here. Now I need the other piece of the hypotenuse adjacent to the leg x. So which piece is touching leg x? Just the 3, which is why I put a 3 in there. Now, I don't know why this part here is highlighted. It should be down here below it, but that's okay. Either way, 3 gets put in right there, and then we cross product, and we find the geometric mean between 5 and 3. Gives the square root of 15. Okay. So all I did was plug into the information into the example. Get that filled into your notes. Okay. We've also got a lot of similar triangles going on here. CBD, this little teeny guy over here, is similar to the big triangle, ABC. When we have ACD right here, the left triangle is similar to the big triangle, ABC. And since that's true, we know that ACD is similar to CBD. All 3 of these triangles are similar to each other. So now it says write a similarity statement with the 3 similar triangles. Okay. So we're going to pick which one I start with. I start with the big one, EGF. Notice how we went from E to the short leg here, and then the long leg. So now we got to pick which triangle we want to look at, the short leg and the long leg. Here we're going to say GHF. Okay, we're using this right triangle here, and we're going across the short and then across the long. Now if we reset and we say GHF is similar to We look over here at this side. We say short leg, long leg, EHG. And then I look at the big triangle again, EGF and EHG. So we're using the short leg and the long leg as our method for getting the similarity statements. Now we say complete the proportion. So we have EF is the hypotenuse of the big triangle, and that's over EG, which is the hypotenuse of the smallest triangle. That fraction is equal to EG over what? And for that we would say EH, which is, if we look here, EF and EG. Sorry, somebody's in my room. So if we look at this, we look at EF. EF is the hypotenuse. Get my markers going on here. Oh my goodness. EF, hypotenuse of the big triangle. EG is the hypotenuse of the small triangle. Now EG is also the short leg of the big triangle, and EH is the short leg of the small triangle. So you've got to be able to visualize it as hypotenuses, and this one also doubles as two different roles. It's the hypotenuse of the small triangle here, but it's also the short leg of the big triangle. So when I compare hypotenuse to hypotenuse, I'm also comparing short leg to short leg, EH. Okay, hopefully that helps explain why we complete the proportion. All right, so now find HF is our question. So if I want to find HF, to me that looks like a piece of the big hypotenuse. So I come down here and I figure out which one I want to look at. I've got two options. I've got piece of hypotenuse over whole hypotenuse. Okay, so I've got the whole hypotenuse, which is good. Do I have an altitude? Do I have the altitude information up here? No, I do not. So that means I'm going to cross off that equation. And I'm not going to use it. Okay? If I don't have an altitude, I can't use that formula. Now I look at this and I say, okay, what's my whole hypotenuse? I start plugging in information. My whole hypotenuse is 25. Now I need to figure out the leg. Well, I got the leg right here, 20. Good. And then I know where I put my other leg. It goes right there, 20. Same figures. Okay, and I still don't know what this piece is. I don't know what HF is. So I plug in a variable. Now I can reduce, cross multiply, and divide, and I end up with x equals 16. Because 20 divided by 5 is 4, and 4 times 4 is 16. So really all I have to do on these ones is decide, do I know the altitude or do I know the leg? Because I'll always know one of those two informations. And when I know that, I can pick the correct equation off of my cheat sheet. Okay, so now let's see here. If AN equals 6, BN equals 9, find NP. So let's go ahead and gotta show all of our work, and I want to label the diagram first. Okay, so now I've got 6, and I've got 9, and I'm looking for NC. Well, what am I looking for? Let's look at the equations down here. Which equation would I like to use? I don't know either leg. See that? So since I don't know either leg, I'm not going to use that equation. So I pick the other equation, I say piece of altitude. Here's 6, goes right there. The other piece of the altitude is 9, and goes right here. Now the altitude, the hypotenuse, part of hypotenuse, they go in their respective locations. The altitude I plug in there as x squared, or x's, and when I cross multiply, I get x squared equals 6 times 9. Now I square root both sides, and I have to find the common factors between 6 and 9, and I pull out my pairs, and I get 3 root 6 as my final answer. All I did was plug them in and cross multiply. The hardest part about this is going to be picking which one to use, and that all I have to look at is do I have an altitude or do I have a leg? Now I look at the next question. Okay, here we go. AN equals 6, CN equals 12. I mark my diagram. Okay, label the diagram. Here we go. I've got AN is 6, CN is 12. Find AB. Find the whole hypotenuse. Now, remember, I don't care about hypotenuses. I care about which leg or altitude do I have. I have the altitude. That means I have to use this equation. So when I use that equation, I start plugging in pieces of information. The 6 is a part of my hypotenuse, 12 is my altitude, and now this isn't x, okay? What this part of the hypotenuse is x minus 6. Now there's a lot of different ways we could have done this, okay? I could have labeled my variable here. I could have called this y, couldn't I have? And solved for y, and then my full hypotenuse would have been 6 plus y. It wouldn't have mattered. But right now we're using x minus 6. So at this point I reduce my fraction. Oh, I would reduce my fraction. It would be 1/2 if it were me. But if we distribute both sides, we add 36 over, we divide by 6. Something's wrong here. 144 plus 36 is not equal to 108. So we've got a little bit of a mistake here in the math. Let's take a look at it. Okay, so besides the little addition mistake here, you get the idea. And what I'm really focusing on is, can you set up this fraction here correctly? If you can set this part up and cross multiply, then the rest of this is just algebra, and I will be very forgiving on minor algebra mistakes. I hope you will be forgiving of mine here. Okay, so let's look at the next example. We're going to go fast. Cn is 3, Nb is 6. We mark our diagram, and now I look and say, what do I have? Do I have a leg? No. Do I have altitude? Yes. That picks my formula for me. I have to use the altitude formula. And I start plugging in pieces of information. X, 3s, and 6s. All right, I got all my information plugged in. I cross multiply, I divide, and I say my answer is x equals 3/2. That's easy. That's all it is. Now, if I label my diagram again, I get AC equals 15. Here you go. AN is 10. Find NB. Now again, I'm looking at, do I have the altitude or the leg? Looks like I've got a leg. That picks my formula for me, and I start plugging in information. What's my whole hypotenuse? Well, it's 10 and x. The and means plus. My leg is 15, and the piece that I want that's adjacent to the 15, notice how 15 and 10 are touching. They're the same part of the triangle. They're on the left side. That means that I use those. I cross multiply, I distribute, I subtract 100 over, I divide by 10, and end up with x equals 25/2. Okay, that looks like a pretty good question. Expect to see some of these on the test. Like I said, there's about 4 of them that you'll be working out like this. Let's go ahead and look at another example. I label the diagram. CB equals 5. Got it. NB equals 4. We're looking for the entire hypotenuse, so that means that this little piece over here is the whole thing minus 4. I plug those in. I don't know what my whole hypotenuse is. I've got this is 5s and this is 4. Notice how I have a leg. That means I'm using the leg formula, which calls for the whole hypotenuse. So I don't have to worry about the x minus 4 situation. I cross multiply, I divide 4 over, and I end up with x equals 25/4. Okay, next example. I look here, I label the diagram. AN is 6, AB is 9, that's the whole hypotenuse, and then CB, that's a leg, so I have to use the leg formula. I plug in my information, the whole hypotenuse is 9, the leg is 6. Now, what piece is adjacent to the leg we're talking about? How big is that? Well, if the whole thing's 9, and this piece over here is 6, then this piece over here has to be 3. Now I cross multiply, I square root both sides, and I end up with 3 root 3. Notice how the 9 is already a perfect square. You could have split it to be 3 and 3 and then pulled out your pair. Either way works. All right, next example. Cn is 8. So I plug this information in. Tons of information for us. Cn is 8. Nb is 6. Find Na, AC, and CB. The point that I want to focus on is right here. I know my altitude. That means I'm going to start with using my altitude. So I start plugging in information. The piece of the altitude, x, over 8 is equal to 8 over 6. I cross multiply, I divide over, and I end up with 32/3. That's x. So since x is 32/3, now I can use, I still have the altitude, but I also have the entire hypotenuse, and I want to find out y. So now I'm going to use the leg hypotenuse, the leg formula. The whole hypotenuse is 32/3 plus 6. I convert that into being a third. I combine them together, and I put 50/3. That's my full hypotenuse. So that's what's going to go on the top of this fraction right here. So I say cross multiply. I get hypotenuse times x equals y squared. That gives me